In the lecture, we will learn how to design the flange-plated beam column flange connection. The flange plate welded to the beam column flange and may be bolted or welded to the beam flange. It is a moment connection and transfers only flexure to the column. Additional shear connection is also required as discussed in lecture 2 to 6 of this connection of the software tutorial. The scenario involves special moment resisting frame beam column connection. The ETABS model for the structure is already provided. We have to design the moment connection for the moment frames. The type of connection in RAM connection is referred as beam column connection FPBCS. In the last video, we designed the FPBCW, that is beam column web connection. In this lecture, we will do beam column web connection. Beam column flange connection, sorry. So let's start with the software. We have to click on BCF, that is beam column flange. Select the beam size that we will be using. First of all, turn off the visibility of the objects that are not of our concern in this video. I'm turning off the visibility of the secondary beams. Similarly, I am turning off the visibility of the beams which have beam column web connection. So now we are remaining with the beams that are having connection with the column with flange plated. So the length of the beam is 20 feet. The column size we are having here is wide flange section of 14 by 53 United States section, and the material properties is A992 50 ASI. Now let's add the load cases. The important load cases are to be considered from the structural model. I'll be generating the automatic load combinations using AISC 710 LRFD, that is load resistance factor design. Now the important load will be loaded from the software. Let's start with the dead load. The dead load flexure values are shown here. The maximum value at connection is to be selected. Since we are designing a typical connection, the values must be closely spaced. The values must be close enough. If there is a large variation in the values, then there must be separate connections for the group members or group of members. Now proceeding with earthquake in X direction moment case. It's up to you whether you are taking the positive maximum value or negative maximum value, but the magnitude must be highest. As of sign is concerned, the sign will be added or subtracted to the dead load, considering the dead load combination and the lateral load combinations. So it will ultimately be added, as the lateral load comes with positive sign as well as negative sign. So if it has to be added or subtracted to give the maximum result, it will be automatically incorporated by the combinations. Axial force due to dead load. Axial force due to earthquake in X direction. Axial force due to earthquake in Y direction. the shear force. Now due to seismic load in earthquake X direction, the axial force you can take as minus or plus, but ultimately it will be added to give up the critical force, as the combination consists of negative as well as positive sign in the combinations for the lateral load when combined with the gravity loads. Click on OK. Now we are done with loading the loads on the connection. Now assign the connection type FP bolted connection, flange plate that is. So as the green color shows that the stress ratio is already within the limits and the stress ratio is less than 1, so it is within the limits. And the green color shows that the connection is following the code recommendations and requirements. Let's start with showing the loads considered for the design. The load considered for design are shown. Construction criteria. You can also consider sheared edge as well. You can change the configuration axis opposite beam, but conservatively I'm taking beam does not exist on the opposite end. You can change the opposite beam size since we are not selecting it, so okay. The column is ending at this story, so I have selected the column end option. The top plate thickness, let's take it as 3 by 8 as 0.5 was too much and the ratio was within the limits. Bottom plate thickness similar to top plate thickness. The beam side connection, we can reduce the size of the bolts furthermore, so it's failing, so it's 5 by 8 is okay. You can change the number of bolts to 2 and 3 as well. The distances, you can see what distances are being changed as written here. If you vary the distances, they will change in the right side figure 3D view. It is recommended that at least take quarter inch thickness for the fillet welds. It is better for the side practice. You can add the stiffener plate as well. Now check the results. It is important that the green tick mark shows here. You can also export the report as well. You can see the DXF view of the connections which can be exported as well. Thank you for watching.